Welcome to the using Docker track. I'm get to do a lot of the introduction today, and today I'm really proud to introduce Liz Rice and Justin Cormick. Justin's with Docker and Liz with Docker Security, and they're going to be thrilling us with the Don't Have a Meltdown talk.
Thank you very much. Hi, everybody. Hi. So my name's Liz. I work for a container security company called Aqua Security.
And I'm Justin Cormack, and I work for a container security company called Docker.
And we're going to be talking this afternoon about some practical steps that you can take to defend your containerized deployment. In this talk, we're going to have demos, we're going to have cartoons, we're going to have extracts from EU legislation. So I'm pretty sure there will be something for everybody in this talk.
One of the things you really don't want is to be in the news with security. You don't want to be the people who get their company names on top of the headlines. I mean, it's good advertising, but it's also terrible advertising, and you don't want it to be that person. You really want to do the right thing up front to make sure that you're not just at panic stations trying to fix these things when it's all gone horribly wrong.
No such thing as no bad news, right? So before we had containers, we used to deploy software. Developers would write software, we'd deploy it onto servers, and then security would typically be done by security professionals as a kind of another stage. It was a kind of separate step. And we'd actually quite often be patching machines, that you'd have software running on servers, and then you'd find out about vulnerabilities, and you'd go into those machines and patch them. Kind of like a sort of sticking plaster approach, or I think in the US you might say Band-Aid approach to security.
But in the kind of new Docker world of where you actually, one of the great things is that you can really build a deployment pipeline and processes that you build a container, you test it, and you have the same image all the way through. You can run all sorts of tests, and you can really build a whole deployment pipeline. And that's really, I think one of the most important things is that you have automation and you actually build, and that lets you concentrate on actually writing tests, testing your software, and being confident when it goes into production that it's doing the right thing. So, the pipeline starts with you typing away at your code, and hopefully thinking about security aspects of your code, then running your tests in your automated CI pipeline, doing the final build and push up to the registry, installing a host to run it on, or running an automated deployment script to just install your hosts, actually running the code, and then observing what's going on and making sure that everything's working as expected and nothing is failing in production.
And at each step along the way of this pipeline, we're going to show you an example of something that you can do to improve security. It's not going to be like a comprehensive list of everything you can do to improve security, but practical steps that could help you defend yourselves against kind of the most sort of common types of attack. And also, at each stage, it's not just about the individual actions that you're taking, it's also about a principle that you can think about at each step. So, for example, we talk about code, but the principle might be thinking about code quality, thinking about security at every stage in the pipeline, looking at kind of security principles like minimizing the attack surface and giving running code the smallest amount of privileges it needs in order to operate. So we'll talk about these as we go through and give you these practical examples. And the first one we'll talk about is code quality. So you're writing your code, and there are things that you can do when you write your code to avoid some really common attacks. It's possible to write code in a way that is vulnerable to attack, and it's also possible to write code in a way that defends itself more effectively.
And so security really is an aspect of code quality. It's good code is secure code, and secure code is good code.
Unfortunately, it's not just about this kind of knowing in your head about security. There are tools that can help with this kind of thing. And in particular, we're going to look at the example of SQL injection. So injection is actually still the #1 kind of attack. If you get like a really bad SQL injection, somebody might write an XKCD about you. And Justin, I think, is going to show us now an example of a tool to help you.
So I implemented the XKCD attack from the cartoon because I thought it would be... so we have a little database of people here, and we have a little script here which basically just runs a little curl against our web application that I wrote very insecurely. And it says, hello, Robert. You can see we've got name equals Robert and then drop table students with a few bits of escaping after that. And the first time it runs fine. We run that again and it says, oh, the relation students does not exist because we deleted it. So that was a bit of a disaster there. So let's add some static analysis to our Docker file. I wrote this code in Go, so I'm using a tool called GAS, which is a tool from Hewlett-Packard, which is really good for running Go code. We just add that into our Docker file, Docker compose build, and it'll run, and it will check the rules, search the file, and it says immediately, right here, SQL string formatting vulnerability. Severity, medium, confidence, very high. It's pretty sure because, as you can see from the code, I just did a sprintf in a terrible kind of sprintf kind of way. So let's go there, and we can basically use a proper way of doing this. Oops. And we should be able to build that, and this time it should build without any errors. Our code's built. So this way, you can, if you run the scanner in your build pipeline, then basically you can actually never even build your file without having run the tests and make sure you're reasonably confident. The code's been analyzed, and so static analysis tools are available for every programming language. There are lots of them available, lots of them open source, there's commercial products as well. There's a really wide spectrum of them. Find something that works with your tooling. The other thing is code review. Your co-workers are also there to help you with security, and someone just reading the code could also find that kind of issue, or different issues, and just say, hey, Liz, you didn't think about this thing when you were writing your code.
It's your code.
Hey, Justin, you should do it properly, not that quick bodge you just did. So code review is also really important from the security point of view, as well as automated static analysis as well. So that's how you can just use tooling to just find things way before they get into production.
Okay, so once you've written your code, you test it. And we are very familiar with the idea of testing in terms of functional testing, unit testing, maybe you have regression testing, making sure that your code changes don't break the existing functionality. But as well as these kind of functional tests, we can also build in security-related tests that can help, again, using automation to help us identify security issues. Sometimes we are kind of encouraged by legislation, to do things to make things more secure. So, for example, for GDPR reasons, you probably want to be encrypting your connections. And this is an example of something where you can use tooling, as Justin's about to demonstrate, to check that you are actually using secure connections with the right levels of, up-to-date TLS and so on.
So here I'm just going to basically, we're just going to we're just going to run a little thing that basically tests whether we've got a little Nginx application, and we're just going to basically bring up our Nginx container that's configured to run TLS, and then basically use a test SSL program to connect to that TLS container and check what ciphers it's using and whether they're up to date and whether there's any security vulnerabilities of any sort. So, so this is the kind of thing that you could just run in your CI pipeline, and it will report back at the end with either a success or failure and a bunch of information about what's gone on. So this copy of Nginx I installed in a very old Ubuntu trusty container just so to make sure it had a few issues. And as you can see, it supports SSL v3, which has been phased out in browsers for many years now, and you should not be using because it's not secure. It doesn't offer v2, which is even worse, but you should. I just use the default Nginx config to do this, and you see there's quite a lot of issues. At the moment, you should only probably be configuring TLS 1.2. That's really it's what the PCI compliance recommendations are, 1.1 and 1.2, or just 1.2. And we can see it's also vulnerable to a bunch of other attacks that you might have heard about. There's tests for Heartbleed and Poodle and all the other fancy named attacks that TLS has had over the years, and it's vulnerable to a bunch of these. So this is very much the sort of test that you can run against everything in your pipeline and hopefully come out green. But the nice thing about these test frameworks, this one's open source, is they'll get updated when there's new attacks, and it'll come along and tell you, whether your containers are vulnerable or not. And so before you put things in production, you've already tested in CI for the different types of TLS, and you can do that, and it just does it as a standalone thing with the container you've already built.
I'll stop that now.
So testing is really not just for functions and code you write. It's also tests security configuration and security best practices and the kinds of rules you need to apply to be secure in production. And so you should have a whole suite of security tests about all the properties that matter, which things are encrypted, that you make sure your logins work correctly. Lots of people test logins work and test passwords work, but don't test if not putting a password works, and all those kinds of things that that you can write a whole test suite for to improve, just to make sure, like any other property, that your programs are secure.
We have got a GitHub repo that we'll be showing at the end that's got links to a lot of these kind of resources
and the
source
code for the tests and things.
Yeah.
So, security policies. Your company is likely to have a whole lot of security policies that you should be in compliance with, and it's really important to actually test for these and make sure that you're actually fitting in with the policies. So, for example, many companies, if you get paid money, which is always a nice, useful thing to have in your company, if you're being able to accept money, you're likely to be need to be PCI compliant, and the PCI compliance regulations are actually very readable. I highly recommend you read them, even if you're not doing PCI compliance, because they're actually a really good set of recommendations. They're one of the things that's been really improved in terms of actually making things readable and understandable. PCI requires that you patch your software and you update it on a regular basis, like within at least a month. Ideally, with containers, you should be able to do it much quicker than that. And you should also look at the vulnerabilities that there are in the software you're using and see whether they're significant. many of the recent large hacks have been people who are running really, really old software, like years out of date with known issues that are, if you look at the issue, they're like, anyone can run any code on your machine from anywhere on the internet, which is obviously a very severe ranking. And so you really want to, but obviously there are sometimes other vulnerabilities that are not so important, and you should look. But the nice thing about containers is you can rebuild, on a regular basis, ideally, more than once a week, and build everything with the most up-to-date software. And also, if you do that incrementally on a gradual basis, you don't have to have rather than updating the code you're using the libraries you're using every 5 years, it's not a big jump, it's just a little incremental piece of work every week. So scanning for updates, so this is what the Docker Enterprise Edition, the DTR screens look like when you've got a vulnerability in the registry. So this is shows you a version of WordPress that's out of date and got vulnerabilities. So EE gives you tooling for just looking at this, and it's nice and easy to use, and you can go into the details of what the security vulnerabilities are. So you can look them up, and you've got links to what they are and whether they matter, and then you can basically wait for everything to go green when you update it.
MicroScanner is a tool that Aqua released fairly recently. And this is, it's free to use, and it's really designed more for kind of individual contributions rather than like a big enterprise deployment. But it's a way for, even for your hobby projects, you could just check that you're not deploying some terrible vulnerabilities by using MicroScanner. It's actually a bit of a sort of unique way of invoking scanning. We put it into, as you can see here, into the Docker file. So when you run MicroScanner, if it detects a high severity vulnerability, it will return a non-zero error code, and then that will fail the build. And then
again, you're stopping things as soon as possible before anything happens, and really making sure that you're not actually running anything at all.
Yeah,
you can't even build.
It's always going to be better, cheaper, less dangerous to find these problems as early as possible as you can in the pipeline. Okay, and there are lots of scanning tools out there, and we've seen Docker's enterprise tooling. MicroScanner is a kind of a cut-down version of what we have in our commercial products as well. And there are other open source tools. I think
Claire's open source. You can just run it yourself in a couple of containers with a database, and it updates automatically. So there's lots of options. It's actually there's a lot of vendors for scanning tools, and there's absolutely no excuse not to scan your containers at all.
Yeah. And then you may want to use the output of that to control whether you're actually going to admit those images to be deployed in your deployment. So being able to have policies and rules around what level of severity you might allow, or maybe you have certain issues that you're going to whitelist because the risk is worthwhile for that particular application. When you deploy your code, the more code there is running, the more code there exists, the more likely there is that there's going to be some kind of vulnerability in it. So if you can have a smaller amount of code, that's kind of minimizing the attack surface. We've just been looking at minimizing the vulnerabilities or identifying vulnerabilities in your containers, but don't forget the hosts. You want to run as little code as possible on your hosts to minimize the possibility of vulnerabilities there, as well as inside the containerized code. There's files inside your container images that could be problematic. There are also files and executables on the host machine that could equally have some kind of vulnerabilities. This is a screenshot from Aqua looking at vulnerabilities that can be found on the host machine.
I mean, yeah, the idea is really, on a container host, you should be running absolutely nothing that is not to do with the container runtime. You shouldn't be running multiple applications or anything on the same host. You really want to just be running you want to run Docker and you want to run everything else in containers on that host. So there are minimal operating systems you can use, like Linux Kit or the old Core OS and things like that, or you can just really just cut down. You can just cut down anything. Just make sure you're not running, other things on the host, and just make it absolutely minimal. We've been working for some years with the Centre for Internet Security on host configuration tool catalogs of checklists really on everything you should do. So the Docker Community Edition benchmark has been out for some years now. It keeps being updated. It's an open process. You can join in. Also the Kubernetes benchmark, and coming very soon there's the Docker EE benchmark and the configurations for Windows hosts. So these are basically just lists of things that you should actually really checklist when you're going through and setting up a host and running on containers. And there's also there's a tool called Docker Bench Security that we have, which basically just goes through your host. This is just running on the laptop, and basically gives you little warnings or informational tests of things you should check against each of the points on those checklists. There's quite a lot of them because this host is running quite a few containers. I think one of the things it'll tell you is you're running quite a lot of containers. But it'll tell you things like there are no memory limits set for any of the containers on this host because it's a laptop and it's kind of not so important. But on a normal host, you should have limits set for all the containers so they can't use up all the memory. It'll tell you that there's 94 images, but you're only using 28 of them, so what are the other ones doing? And it'll give you pass or fail or information. So it's a kind of there's a lot of information in there, and it's worth reading it in conjunction with the actual written benchmarks to understand what these are about. But it's a useful tool that we've got that basically helps you understand what your host configuration and Docker configuration. There's basically also the there's also the Docker tooling for installing hosts that actually configures things in the right kind of way, and you can use those as a kind of starting point as well. Least privilege. I mean, least privilege is one of the sort of most important, but maybe most neglected security principles. Only let your code do exactly what it needs to be able to do and no more, and really lock it down into the smallest box you can. This might be kind of, hard, but, if it doesn't need to be able to write to a volume, don't give it write access. If it doesn't need to be able to, it doesn't need privileges or it doesn't need network access, then don't give it those. If it needs to make a sandwich, then maybe it should be able to make a sandwich, but it shouldn't be able to ask you to make a sandwich for it. It shouldn't ask for sudo permission if it doesn't need it. These things are, you should be asking, why is this container asking me to make a sandwich? I mean, I'm not here to make sandwiches for my containers. So Liz is going to demo what goes wrong when you give your containers too much privilege.
Yeah. So in this example, we're just going to see how you can give away too much privilege to a container through a simple mechanism like bind mounting a directory. So I might run, I'm just going to use Nginx as an example, but I'm going to mount the etc. Directory from my host, and I'm going to run a shell. Okay, these are both windows onto the same virtual machine. And at this point, I'm just going to check that I don't have a user called attack. Now, as the user vagrant, who is not a kind of a super user, I could try to add a new user called attack, and I'm not allowed to. I don't have the privileges to do so. Now, I just ran this container as the same user. I was Vagrant, and I ran this Nginx container. But I am now running as root, and I can add a user called attack, and I'll change the password for that. So, because under normal circumstances, that would just be adding a user inside the container. But because I have, perhaps rather recklessly, shared the etc. directory from my host into the container, that user does now exist on the host machine. And I know what the password is because I just set it myself. So if I was an attacker, well, apparently I don't know the password, but yeah. The principle, yeah. If I was an attacker and I was able to compromise that container, the fact that it had mounted a kind of sensitive directory, if you like, / etc. from the host, shared an awful lot of privileges into that container. So as an attacker who somehow managed to compromise the container, I can very, very easily escalate to taking over the whole host. So,
Yeah, definitely. You definitely want to minimize bindmats and not allow bindmats from sensitive areas. And you want to obviously not run stuff as root in the container, or that would have not been possible anyway. And the privilege flag is obviously a dead giveaway as well, it's from its name. Docker EE already comes with a set of rules to stop bindmats by default for most non-admin users, and that's configurable. Also, you can set up an all-C policy, for example, to do that yourself. So there's various ways to actually control and restrict these things happening kind of by mistake or without users kind of realizing and making, so you can basically lock down your installation. And just not let people run containers with these problematic configurations.
Yeah, I think you can use these tools to kind of police these issues, but it's also kind of it's almost like a code review thing as well, having your developers knowing the risks of things like mounting sensitive directories or using the privileged flag could go a long way to sort of preventing some of these issues.
Defense in depth. I think really you've gone through and you've done all the things you can and everything. You've built things and tested things as securely as possible, but something can still potentially go wrong. And if you're not actually monitoring the host at runtime, you might never know you've actually been hacked. So you really need, there's a few things you need. First of all, you need multiple lines of defense. If something crashes into a barrier, it's good if there's another barrier behind the first barrier, just to make sure that you're not plowing straight into the spectators. You really want to be able to get visibility to make sure that you're not, something really unexpected is not happening, and when it does, that it's not the beginning of a horror story or a newspaper headline. It's something that you can actually, you want at that point to be able to stop what's going on, investigate, take a look, and remain in control of the situation if things that are not happening as you expected.
So I'm going to show basically a way that we can use Aqua to detect unexpected behavior. So let me make this a bit bigger. I've got a WordPress deployment running on this virtual machine. And it's just kind of ordinary WordPress, but I've also got, I'll make this a bit bigger as well, a plugin here called Zen Mobile, and it has a vulnerability in it. And I have a script that I can use to attack that particular vulnerability. So this is essentially trying to install a cryptocurrency miner into this WordPress deployment. And if we're lucky, it will start executing. There we go. Right. So if I were to exec into that WordPress container, and I'm going to run a shell so I can see what's going on. So if I look at this now, I can see like virtually all of my CPU is being used by something kind of a little bit suspicious.
Systemd.elf.
Yeah, I'm pretty sure that isn't something that's normally distributed as part of WordPress. If I'm really lucky, if I go to my Minergate, I'll find, maybe not. It's not super reliable. There we go. It's very small. But I am actually now mining one currency, apparently. So thanks for the electricity. That's great. I'd better stop that. Let's kill 445. So yeah, that stopped working. Now, I'm going to use Aqua to kind of constrain what that WordPress container is allowed to do. So currently it's got no profile, but I'm going to attach a profile that here's one I created earlier called WordPress Runtime Profile. And I'll just go and take a little look at the settings. So one of the things that we can do here is observe what the normal set of executables should be for this particular container. And we can also get a set of the system calls that this container is allowed to execute. So I've now attached that profile. I've sort of associated that with my WordPress container. I should probably have just confirmed. Let's just check. There's nothing in here that looks like systemd.elf. If I can spell it right, systemd. Yeah, it's not finding anything. Right. So let's try and exploit it. Run that exploit again. Okay. So it's downloading the miner again. And it's slightly different this time. It says that the miner has landed, but it's not sure whether it's actually been able to execute the miner. And if I take a look in our audit log, we should see, I'm just going to check that that's the most recent one. Yeah. This is my exploit trying to run systemd.elf, but it's been protected. It's an unauthorized action that particular runtime policy has prevented. You might also notice I didn't have to restart the container to do that. I could just attach the profile, and basically anything outside of what expected behavior we defined, anything outside that, we can either block or we can put it into a kind of an alerting mode where we'll see logs instead of prevention. But that's a good way of protecting yourself against cryptocurrency miners on your cluster.
Something that we've seen a fair amount of recently with some high-profile things. So you see, there's a whole set of runtime protection tools. There's tools like Sitcom and AppArmor that we build into Docker and protect you by default. There's commercial tools like Aqua and other ones that will protect at runtime. And recently we've been seeing interesting activity with new types of runtimes like Google's gvisor and Kata containers, things like that, which are all very new, but they're quite interesting for containing some sorts of code that you think might be hostile. But you need some kind of runtime protection just so you know when something's gone wrong. You can't just trust that nothing ever will, and it's fine. Otherwise, you've got no idea when something has happened that shouldn't have done. You've got no idea that you've actually really been hacked. So what we can see these kind of different actions in the different parts of the pipeline.
Yeah. So we've had like an example that we've shown you of just one thing that you could do at each of these 6 different stages. And there are other things as well, but these 6 things would kind of give you a pretty good, set of defenses against a lot of common attacks.
And these are examples of principles, and these principles are the important things. Code quality, make sure that you test for security, enforce your security policies all the way through the stack, minimal attack service and least privilege for runtime, and defense in depth. When it's actually after you've shipped. These are really the important things that kind of you should think about overall and how they fit in with your business.
Or at least that's the advice we're giving you. So we'd finish with it. This just seemed too appropriate to...
We can see what the advice the fortune cookie gives us.
That's a good idea. Yeah. So you may or may not choose to take our security advice here. We kind of like that. What does it say?
It says from 10 to 10,000 containers for your microservices with Docker Container Platform. But it's
okay.
But it doesn't say they should be secure ones. But I think it's got it wrong.
We'll have to work our way through all the fortune cookies. If you're interested in finding out more about some of these tools that we've shown you, there's a bunch of links in this repo that we've put together.
And there's the source code for some of the demos as well, so you can take a look at it. And we should put some more links in there probably as well.
Yeah, we might be updating that a bit more over the next day or two as well. Okay, so with that, thank you very much, and we might have about 1 minute for questions, I guess. Great.
There's a question.
There's a question, great. Oh, right, okay. So I think the question is what the profile is that we associated with WordPress. We do actually have a set of kind of standard, my machine's frozen for some reason. Yeah, so we have some kind of basic starting point templates for some common things like Nginx and WordPress and MySQL or what have you. I actually handcrafted that one a little bit further because I wanted it to get to the point of executing the cryptocurrency miner. Our default profile would have actually caught it earlier than that, but it wouldn't have been such a nice demo.
You shouldn't customize your security for your demos, but...
Yeah, so the question was about the difficulty of generating those kind of runtime profiles. And I think that is very true. I mean, particularly for things like SecComp and AppArmor, there are some starting points out there. There are some kind of community-generated profiles. There's the default profiles that Docker has.
Yeah, there's some stuff we've been working on to try and make that easier. It's definitely non-trivial, especially if your application changes what it does a lot. It's hard to lock it down really tightly, and you can kind of do it more loosely and not so exactly, but otherwise you have to retest the profiles every time you're changing these. It's kind of painful, but yeah, we're definitely working on tooling to make that easier.
It's one of the things that, it's why commercial security tooling exists, because it's not an easy problem to solve. So, yeah.
Can you make a profile that denies everything and see what your app really needs to run?
Yeah, that's one good way of starting.
Yeah.
Yeah, you can basically put it into logging mode and see what gets logged.
That's how AppArmor.
Yeah, you can AppArmor's, and I think that's a good way of starting if you're not sure at all. Is just put it into logging mode. I think we're out of time, so we'll be around if you want to ask more questions.
Yeah, we'll be here. Thank you very much.